Now, bias is another problem. And here's an example from November 2029. I'm not sure if it still works. It changes continuously. So you enter something like a doctor and a nurse have a break. She has a tea and he drinks coffee. Question is, what did the doctor drink? And then the answer is, the doctor drinks coffee, which is in two ways biased, because why would the doctor be a man? He drinks coffee. But the other thing is that normally when we write, we keep things in the same order. We say doctor and nurse, she and he. That normally means she is the doctor and he is the nurse. So it violates this pattern, and it has seen these patterns many, many, many times because of the fact that doctor and he is more strongly associated and she and nurse is more strongly associated, which overrules this thing. So this is where unlogical answers come from biases, which are stronger than the association which would produce a logical answer, because there is no logic in it. Yeah, so if you put everything together, you really wonder, why are we using this? It's making an ethical claim, hallucinating, it doesn't know what to do with rare, non-frequent data, it's not transparent, it doesn't acknowledge, it's biased, it consumes an enormous footprint, but just make one question is the same as charging your phone. So you probably shouldn't use it. But there are things you can try to fix it. But everything you try to fix it takes away a little bit of the myth of these models. Actually, it turns it into a pretty classical system, and there is no general AI or intelligence anymore. So there are basically one way of doing it is afterwards filtering. This is what OpenAI is doing. If you observe behavior you don't want, you either try to train it more to avoid this, or you filter it with this reinforcement learning trick that in this case it should not give this answer. And you can even go into the actual vocabulary of the model and take out words that you don't want. So you can take out names or slurs, and some people even hack the actual weights in the model so that biases no longer occur. So there are a lot of things there, but everything is a trick. Hacking the vocabulary and the parameters is almost undoable because these things are too big and too massive. And the other strategy is, avoid these things from happening by looking at the pre-training data. So we see that, okay, we can give more data. We can make bigger and bigger models, which means that we can capture more less frequent information. So it's not forced to generalize as much as a smaller model, and it can maintain more nuances. So that can avoid a little bit some of the errors, but we don't know how big they have to be. And the bigger we make them, the more training we have to do and the more energy we will consume. And also usage of the models becomes difficult. Now we can also clean the data. We can remove the bias. We can remove unethical content or respect human rights in any kind of statement, such that we create only, let's say, correct associations. But when we do that, we also remove stereotypes, which are shortcuts that we use in our daily life to do all kinds of efficient reasoning without going through all kinds of alternatives. So stereotypes and biases also have a positive side next to a negative one, and it's very difficult to differentiate between them, to keep the good part and drop the bad part. So if you do this radically, you will have a system that will only talk about persons and no longer about men and women, for instance. Then there are ideas about curriculum learning, to do this in a very sly way before you expose a model to something which may be unethical. You need to first learn the model, what that is, so that it can judge this or train it. But these are all kinds of ideas, and nobody has shown that you can use this to build a big model that performs as well as the ones that we have. The same for value aware, is that when you exposes a model to these texts or these sentences, you should also expose the kind of quality of the information or the association that you presented, or any kind of value that you associate with it, so that with a particular sentence, it's not only can output, let's say, hate speech, but also will be aware of the fact that it is outputting hate speech when it does it. Also, these are just ideas, and people work on this a little bit, but it's not fully shown to be able that you can build a model as we have. Now, the other one is augmented models, so retrieval augmented or knowledge augmented models, but basically that changes the architecture of the system to a classical architecture in which the retrieval systems or the knowledge graphs or the knowledge bases, they are the core of the intelligence. They do the real reasoning and decisions. And the language model is either making it easy to ask questions or easy to summarize the retrieval results. And all of that, I think, is a little bit disappointing that these models, even though they have these emerging capacities, and it is very nice that we have now this conversational interface to use these powerful models, they're really very far from artificial general intelligence, in my opinion. Some things that people do is, for instance, to force it to be explicit about the reasoning that is necessary to get to an answer. This is an example from a paper where they give these kind of puzzles to a model. So like Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? The answer it should give here is 11. So this is the example. And then you can give it another puzzle. A juggler can juggle 16 balls. Half of them are golf balls. Half of the golf balls are blue. How many blue golf balls are there? And then the answer is 8, because it doesn't realize that half is applied twice to the subset. It just creates an association between half and the only number that is given here, and it returns 8. This is the zero-shot one, where you have to say that the answer has to be in Arabic numerals, but that doesn't help either. Now, they found out that you can actually not just give an example in which you make the counting explicit, so you really instruct it like if you solve this puzzle here with Roger and the tennis balls, you actually need to create a equation in which you add the numbers to the total and then produce the answer. So this does help. So now you can see if you do the puzzle here, then it tries to mimic the example in producing similar things from what it has seen, and then it comes up with 4. But they also found out you don't really need to be that explicit. Somehow, if you only prompt it with, let's think step by step, you kind of trigger a behavior in the system in which it is trying to explicate or make explicit the intermediate reasoning steps. It is also triggered to give the correct answer. And in this case, it doesn't give you the equations, but just a verbal version of the text and 4 blue golf balls. So this is why people think there is this emerging logical thing that you can trigger inside the system. And nobody knows exactly how it works internally and why this phrase seems to work. And you can have all kinds of variations of these phrases, and they all do slightly different things. There is very little understanding of how this precisely works. Another thing that you can do is, if you force the system to answer, it will give you an answer. If you tell the system you're wrong, it will give you another answer, and you can do this forever. But you can also train it that giving by trigger it or instruct it basically that with certain things you should not give an answer. So that means it gets a behavior which mimics that it knows what it doesn't know. And here they give these examples come from OpenAI. So if you instruct it, okay, you need to give answers to, if you have a prompt like this, then you need to give an answer like that. But if you prompt it like, what is dorsal plexity, which is a nonsense word, which means it will break it down into sub-phrases, and it will have a very low a representation that creates an answer with a very low probability internally. Don't give an answer, question mark. And the same with this one, don't give an answer. But if you have something obvious like George Lucas, you should give an answer. And by doing this, you kind of adjust the behavior to not give an answer in certain cases and only give an answer in other cases. Of course, what you will get is a system that will typically give answers to things that everybody already knows, which is the frequent data, like who is George Lucas. And it will avoid giving answers for more rare things, things it doesn't know or are just less probable. The question is, how useful is such a system that just answers things that we already know? So the augmented language models is basically now the big thing, retrieval-augmented generative ones. They basically mean that the language model is moving to the periphery of the solution. So you could have a question by a user: how can I fix a flat bike? Which is the prompt for a language model, not to produce directly the answer, but basically translates this into queries that it sends to things in the back, like Wolfram Alpha, which is very good in doing calculations or calculating distance, or Wikipedia, in which you can get answers on certain concepts and things, or Google or Bing or X to get very recent information rather than going to outdated associations, or even instruct a robot arm to move. So the actual behavior that you get as a response is coming from classical systems in the backend. And the large language model is only interpreting your question as a prompt, maybe even doing some step-by-step reasoning by figuring out what part of the thing should be sent to which system in the back in order to produce the answer. And another model would be where you actually have the LLM at the end of the pipeline. So you have your query over here, you just send it to a standard search solution, which goes to all kinds of back-end repositories, or your specialized or your legal archives that you have. It will return a top ranking of documents, and you can now either do Q&A over the top ranked documents only because you put all of that in the prompt, or summarize it or translate it. And then the large language model is just a fancy answer machine that gives you a nice summary or response for your question. And of course, these two architecture could be combined in one, but then still the intelligence is in the backend models. This is an example from a guy from Microsoft showing how this works, but it's basically the same principle. You have an internal knowledge base, which is indexed, and through ChatGPT, you do retrieval over the knowledge base. You get the top X paragraphs. So this combines LLM at two sides. One is the user question is mapped into a search engine query, a complex one, which goes to the knowledge base. We get the X paragraphs back, and then the large language model is now generating the answer only on those. And this is pretty advanced. This is the actual prompt for the example that he gives. And you can see how explicit you have to be in instructing the model to behave accordingly with the search engine in the background. You have to say things like use you to refer to the individual asking the question, even if they ask with I. So simple things. Answer the following question using only the data provided in the sources below, which you will follow. Tabular information return it as an HTML table. Do not return Markdown because users don't want that, etc. So you have to be very explicit about all kinds of things it could produce potentially, which ones you want and which ones you don't. And here's an example, a question like this. Then you will get sources, which you have the format as here, like info text and the PDFs that's shown here, which have titles. The answer then should be something here where you have the pointers to the original sources inserted in the answer. and that then trains the behavior. Okay, I think this is what I thought back in December about the future, which probably is now already different. So
What do you
multimodality.
think today, maybe?
Huh?
Well,
Yeah,
maybe we can discuss what do you think today about the future?
yeah. Well, I mean, the multimodal foundation model is already there. That is Chat GPT Omni, for instance.
Yeah.
Bigger and better, yes, sure, they will be. But actually, there's also a tendency that's still true, smaller and just as good. Uh, a lot of people claim that in the end, these proprietary models will be catched up by the open source ones. We already see this with Llama and Alpaca and various other models. They are not as good as ChatGPT, but developments go very fast, and it's kind of the advantage that OpenAI has. I think will just slink gradually, and yeah, I think one of the biggest thing changes that is the expectation of the general public and the users is that they all have seen, wait a minute, I don't need to do search or go through all kinds of search results and figure it out. I can really just have a very easy interface. And the question is whether people will still want to use these classical interfaces and only want to use something that they call conversational AI as interface or all kinds of other functions, whether these are retrieval-augmented generative AI, ARCs, or other augmented models or personal versions of the system.
Both lawyers and, for instance, marketing managers have a perception that the models study their own data, their own generated data, their own outputs, and that what we get from the large language model is getting more and more standardized because the data sets are de facto outputs, previous outputs
Yeah.
of LLMs. So
Yeah,
what do you think as data scientists? Is it true? This perception is
yeah,
true?
there have been studies already that show that this will happen. So that they mimic the situation that in the case of training a model, that if you replace part of the real training data by synthetic training data, that these distributional biases that I talked about will only get stronger and stronger. Basically, what you can see is that the long tail is kind of cut off bit by bit by bit because the volume of the obvious data, if you ask who composed blah, 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 it will come back with Ludwig from Beethoven. So it will always generate the obvious things more likely than the tail things. So that the tail will start to disappear slowly and get shorter and shorter and shorter and shorter because of this. Unless we refrain from using it and we keep on producing real data as humans massively against the AI. But yeah, so it will be also kind of kill itself in a way.
Where on the road to artificial general intelligence we are now? What's your opinion? Is it the beginning, the middle, or are we heading there?
I think that, um, for instance, if I look at the way we are using it, is that we use this model in order to interpret the text and then do something with the interpretation in a classical way. But you have to really have to make sure that it is giving you the right interpretation. There are no all kinds of tricks. So you have to do a lot of engineering to leverage the power of these models, and they have enormous power in the right way. I don't think we want. I do. I really believe that we want to have an explicit control through some kind of explicit symbolic system on top of this. And so these retrieval augmented approaches and also knowledge augmented approaches are the first signs that people are building that as real solutions. But these solutions are not, they're maybe not so special as we thought it would be. So So do we want to have some broad notion of general intelligence? No, I want to know that if I want a system to do calculations of distances, I wanted to use Wolfram Alpha because it's very good in doing it. And they really built a system dedicated to that skill. If I want to know about the weather, I go to something else. I don't want to somebody make up the weather. I want to have a real source about the weather. I cannot take care of my crops if I am relying on some kind of statistical mashup of the weather for tomorrow, is it? So I don't think you can have one kind of powerful model as OpenAI is building to provide these broad spectrum of very specialized functions. And I think we really want to have quality for these functions. If Google is directing me on the road, I don't want to have a made up story, is it? I want to have the actual information, how busy it is now today. So you really have to build a specific machinery to get it. And you cannot make it up out of associations. So it's going to work.
Thank you for sharing your insights with us today. It was an enlightening discussion, and I know that our listeners have gained a lot of from your expertise. It was
You're welcome. You're welcome.
great.
Good luck with the podcast. Bye bye.